right, Algebra 6-2. So we're talking about intercepts here. So consider the line on the graph. What can we say about it? What do we know is true here? Well, I just said something about the word intercepts. So what do you notice? Well, what I notice is the only thing I can tell you about this, I could tell you the slope. I do see the slope as a half. That's great. And I could actually give you the equation line. But what I want to look at is I want to look at these intercepts, where it's crossing. So notice the x, where it crosses the x-axis, it crosses at the ordered pair over 4, up none. That's the x-intercept. Now, a lot of books will just say, hey, the x-intercept is 4. And in this case, the y-intercept is -2. And that's fine. But I do want them, for myself, to be written sort of as an ordered pair. Okay, so that's what we notice. We're noticing the intercepts. Pretty easy idea. Where is it crossing the axes? So no matter where a line crosses the y-axis, what do you know to be true? So, I mean, if it crosses there, or maybe here, or down here, or maybe coming that direction, what do we know is true every single time? Well, I don't know. That's the ordered pair 0, almost 3, let's say. This guy's what? 0, -2. This is 0, negative. What is true every single time? Every single time it's crossing this axis, the x value is 0. We don't know what the y is. The y can be different. As we see, it crosses at 3 and -2 and all these. But what we do know to be true is we know that when it's crossing when it's crossing the y-axis, the x value is 0. Well, let's change that also. No matter where the line crosses the x-axis, what do we know is true? Well, let's say it crosses there or there. Those are what? 3, 0 and 2, 0 and whatever. We know if it crosses the x-axis, the y value is always going to be 0. The height has never gone up any. So if you're touching this line, your height has not changed. Okay? So we don't know what the x is because it could be anything, but we know that the y value will be 0. And that's important. So how do we find the intercepts for a function like f of x equals 5x minus 20? How would we do that? Well, let's think. Here's a line. Okay. Let's do the x-intercept first. Well, if I'm crossing right here, I've gone over something and up what? Nothing. So I know the y value to be 0. So this equation, now the equation, it says f of x, but it's the same thing as 5x minus 20. We know the y value is 0, so we can solve it to find what the x value will be. We add 20 to both sides. 20 is 5x. Divide by 5, you now know x is 4. We know that crosses at 4, 0. So the x-intercept is 4, and I like it written as the ordered pair 4, 0. Now, what about the y-intercept? Okay, well, what do I know is true? It crosses the y-axis there or there or there. Well, if it crosses there, I know it's 0, and then I don't know the height. But I do know that every one of these, the x value is 0. So I can go back to the equation. Y equals 5x. Well, what is x? We just said it's a 0. Guaranteed. 0 minus 20? The y value will be -20. The y-intercept will be -20. So that crosses at x being 0, y being -20. So we can always find the x-intercept and the y-intercept. The x-intercept, we plug a y value in of 0. For the y-intercept, we plug an x value in for 0. Now, how do we tackle a problem that says this? If the domain of f of x equals -2x minus 1, so the domain is 3, 5, and 10, what's the range? In other words, if you plug an x in of 3, what y value are you going to get out? Well, that's pretty easy. Let's do it. -2 times 3 minus 1. -6 minus 1. We get an answer out of -7. So one of the range values, when we plug that 3 in, is -7. Then it says, hey, plug 5 in. -2 times 5 minus 1. That'll give me -11. And finally, plug 10 in there. -2 times 10 minus 1, -21. The range are simply the y values that you get after you plug those x values in. That's all it's asking you to do. Pretty easy. Now, finally, let's consider what we could add to the two unknown values, these two question marks, in the t-chart to make the relation not a function. Remember, to be a function, for every x, you can only get one y answer. So in other words, if I plug x in to be 3, I should only get a y out of whatever, 10, let's say. I shouldn't get an answer out of 10 and 12 and 14. I can only get one answer out. So what can we plug in here to make this not be a function? Well, there's a whole bunch of things, but since they said when they plug x in to be 5, they get -2, we could say, hey, when you plug in 5, you also get 4. That would make it not a function. Or we could say when you plug in 5, you get 10, or you plug in 5, you get whatever. We could also say, hey, here it said when you plug in 4, you get an answer of -3. We could say, hey, when you plug in 4, you get an answer of 10. That would mess it up. And finally, we could also mess with the 7. It says when you plug in 7, you get -9. We could say, hey, you also plug in 7, you get 11 out. Any of those would make it not a function because it would be plugging in an x value and getting two different y answers, values out.